Network diagram. Here we are going to learn about how to use network diagrams to represent activities of a project so that we are able to manage the project better. Diagram of project activities that shows a sequential relationship that are represented using networks, that means arrows and nodes in a network. There are two ways to do that. One way is to show activities on arrows. This is called AOA, or activities on arrows. And the other way is to show the activities on the node. So this is AON, activity on node. So these two network conventions can be used to represent a project or the activities in a project. Activities, as you know, is the project step that consume resources and require people to work on, staffs, etc. And events can be simply thought of starting and end of activities. So let's see how these network diagram work. Let's see an example of a network diagram for a project. Let's take building a new department in a bank as the project that we want to represent it using the network diagram. For such a project, the activities required to do are locating the facility, ordering furniture, furniture setup, remodeling, interviewing for the staffing, after interviewing, hiring and training, and then at the end, moving to the new department. So there is a precedence relationship between these activities. Some has to be completed before the others. So we're going to represent this project and the activities of this project using the two networks that we know. The activity on arrow shown on the left. So in this setup that you see here, we start at node 1. The node doesn't represent activities. Activities are represented on the arrows that you see here. Locate facilities. After that, we order the furniture and remodel, and also furniture setup after we have got the order. And then we also need to have to do interview to hire a staff, and then hire and train the staff, and at the end move in. So the precedence relationship between these activities holds true here. We cannot hire before we interview people, or we cannot move in before we locate the facility, we order furniture and set up the furniture. So the precedence relationship must hold true in any type of diagram that we use. We can actually represent the same activities for the same project using the other network diagram. That's activity on node. In this setup, the activities are shown on the node here: locating facilities, interviewing, hiring and training, remodeling, ordering furniture, furniture setup, and then moving. Again, the precedence diagram here holds true. The only difference between the network on the left and the right is that on the left we show the activities on arrows, and on the right we show the activities on the nodes. Both of them mean the same thing. So now let's actually find a path. A path, what is a path? A path is a series of connected nodes with arrows that goes from the beginning to the end. So for example, one path for the network on the left is 1, then going to 2, then going to 4, then going to 5, then going to 6. So 1, 2, 4, 5, 6 is a path from beginning, node 1, to the end, node 6. Now let's find a path for the network on the right. So in the network on the right, we actually have added a virtual or dummy node here, which shown by S because this is the beginning, S. So S goes to 1 and 3. So one path here could be 1 to 2, S goes to 1, and then goes to 2, and then goes to 6, and then goes to 7. So this is one path here. You can find other passes here, for example, For the network on the left, 1 to 3, 3 to 5, and 5 to 6. Or 1 to 2, 2 to 5, and 5 to 6. And for the network on the right, there are other paths as well. For example, S to 3, 3 to 4, 4 to 7. Or S to 1, 1 to 5, and 5 to 7. So we can actually list all the possible passes from the beginning to the end of these networks. Now, we see that there are different options, different passes that can get us from the beginning to the end. Then let's now talk about the critical path. Among the passes, there is a path that has the longest time, and that's called the critical path. The path with the longest time, because each of these activities would actually take time to be completed. And the path that takes the longest, it's going to be called the critical path. And the activities that are on the critical path are called critical activities. So now that we learn about critical paths and critical activities, we can talk about a slack. A slack is the difference between the length of a path and the length of the critical path. The two network diagram that we learned about, the activities on arrows or AOA and activities on nodes or AON, differ from each other on representing activities of a project. Here we want to take a look at key and challenging scenarios that these two diagrams differ from each other. Suppose that we have three activities, A, B, and C, and there is a precedence relationship between these such that A needs to be completed before B starts and B needs to be completed before C starts. So this is how we show this scenario when we use an AOA diagram. As you see here, the activities are shown on arrows here, activity A, activity B, and activity C. And this is how we represent this precedent relationship. First, A needs to be completed, then B needs to be completed, and then C needs to be completed. So this is how we show this precedence relationship using an AOA. Now let's take a look at an AON network. In AON, we show the activities on nodes. So A is before B and B is before C here. So here, A needs to be completed before B is completed and B is completed before C is completed. So this is how we show this scenario in these two types of network. Let's now take a look at another scenario. Suppose we have three activities A, B, and C, and A and B needs to be completed before C starts. So C cannot start before A and B are completed. Here is how we can do this in AOA network. So as you see here, activity A is on this arrow, activity B is on this arrow, and these A and B must be completed, and we get to this node here until C can start. So let's now see how this is done on an AON network. In AON network, we show activities on nodes. So A on this node, B on this node, and both of A and B must be completed before we can start activity C. So this is how we show this scenario using AON. Now let's take a look at the third scenario. In the third scenario, activity A must be completed before B or C can start. So B or C cannot start until A is completed. So in an AOA diagram, activity A is shown on this arrow, and it must be completed before B or C can start. So B or C cannot start, neither of them can start until A is completed. Now let's see how we can do this on an AON network. Activity A is shown on this node, and activity B and C cannot start until A is completed. That's why the arrows that goes to B and C comes out of A. That means that A must be completed before B and C. The fourth scenario. In this scenario, both A and B must be completed before C or D can be completed. So in an AOA network, this is how we show it. Activity A is on this arrow, activity B is on this arrow. Both A and B must be completed, and we must get to this node here until C or D can start. So C or D cannot start until we get to this node right here, and that's where A and B are completed. So now let's see how we can do this in AON network. For AON network, as you see here, we show the activities on the node. So A is here, B is here. A and B must be completed before C and D can start. So when you want to start C, for example, these two arrows that comes from A and B must be completed. That means that both A and B must be completed. If you want to start D, as you see arrows that come from B and A, that means that A and B both must be completed before D can start. So this is how we show this scenario using an AON diagram. As you see before, for the AON, we actually had an example that we added a dummy node, and that was the start node. We show it by S. So that was, for example, this is just an example. S start goes to A and B. So S doesn't exist really. It's just we added, this is like a dummy node here that we need to add to start the project. So this is not only true for AON, sometimes we need to do this also for AOA, but instead of a dummy node, we have to add a dummy arrow. So let's see, take a look at these two scenarios. We need to use a dummy activity to clarify relationship. The first scenario is that to separate two activities that have the same starting and same ending. So for example, suppose that activity B and activity B, as you see here, have to go to end node. The end node is here. So that's why we need to add this dummy arrow here. So you would have the same start here and the same end here. So this dummy activity that is added here, it doesn't really exist. It's not time consuming, it's not resource consuming, it's just for the purpose of showing that these are connected. This is how the logic works here. The logic is from the start to B activity B and then to activity C and the end. Next scenario is when a set of activities share some but not all precedence activities. So as you see here, we add actually this dummy activity so that the activity B can be a precedence, can have a precedence relationship with activity D. That means that it needs to be completed before D, and also it needs to be completed before C. So that's why we have added this dummy activity here. When we want to manage a project, we usually come up with an estimation for the time that it would take for each activity in the project to be completed. Our time estimation can be deterministic or probabilistic. If we are fairly certain about time estimation that we come up with for the activities in the project, then that is a deterministic time estimation. On the other hand, if we are not really certain about our time estimation, if there is an uncertainty and variation in our estimation, then that's a probabilistic time estimation. Here we're going to see examples of network diagram and finding the critical path and the length of the project using time estimation that are deterministic. Here is an example of network diagram with time estimate. So here we have an activity on arrows or AOA network. So as you can see here, we have activity locate, and it's going to take approximately 8 weeks. We have another activity interview. It's going to take 4 weeks of our estimation, and then remodeling ordering furniture, set up, hire and train, and then move in. So this is all the activities that we need to complete with the time estimation given on the activity on arrows AOA network diagram here for the building a new department for a bank. So what we want to do here is, first of all, we want to find all the passes possible from node 1 to node 6, that's starting from here and going to here. So we want to find all the passes first of all, and second of all, we want to find the lengths of each pass, and then identify the critical pass and the expected lengths of the project. Also, the amount of slack time for each pass that we have. So please pause here, try to work on this problem and answer these 4 questions. And after you are done, come back to see the solution. Let's solve this problem. So I have developed this table here to keep track of all the things that we need to find, including the passes, all the passes we want to find it, and then the lengths of each pass, and then the slack, given that we know the critical pass and the lengths of the project. So let's go ahead and find all the passes here. So one pass, for example, is going from 1 to 2 to 4 to 5 to 6. So I'm going to write it here as 1 to 2 to 4 to 5 and to 6. Now let's find the lengths of this path. So that's 8 from 1 to 2. From 2 to 4, that's 6. So 8 plus 6, that's 14. Plus 3, so we have 17. Plus 1 here, and that's 18. So the length of this path is 18 here. All right, let's go to the next path. So the next path, I'm going to clear this up. The next path. From node 1, we go to node 3. So that's going to the interview, and then we go to node 5, and then we go to node 6. So that's 1, 2, 3, 2, 5, 2, 6. Now, what is the length of this path? 4 plus 9, that's 13, plus 1, that's 14. So that's 14. The next path. Let me clear this up. From node 1, we go to node 2, and then we go to node 5, and then we go to node 6. So that's 1 to 2, 2 to 5, and 5 to 6. So let's find the length of this path. So that's 8 plus 2 to 5, so that's 11. 8 plus 11, that's 19, and 1 is 20. What is the critical path? The critical path is the path with the largest length. That means 20 is the largest length, so the lengthiest path here. So our critical path is this critical path: 1 to 2, 2 to 5, 5 to 6. So this is our critical path, and this means that this is going to be set up the length of the project. So the project cannot be completed less than 20 weeks. At least 20 weeks is going to take. Right, now that we know this, let's find the slack. The slack is the length of each pass subtracted from the length of the critical pass. So for the critical pass is 0. For the slack for this path, 1 to 3, 3 to 5, 5 to 6 is 14 out of 20, which is 6. And for the first pass, 1 to 2, 2 to 4, 5 to 6, that's 18 out of 20, which is 2. So the slack is 2. Here is the final solution, a typed out answer and a neat table here, as you can see. As we saw previously, the critical path for this problem is from 1 to 2, 2 to 5, 5 to 6. So that's 1 to 2, 2 to 5, and 5 to 6. And it's going to take 20 weeks at least. So, which is the greatest among these three. And that's going to be the critical path. And then we can compute the slack. The slack of flux here is 0, here is 6, and here is 2. Now that we know the critical path and its length, that's going to determine the length of the project as well. So the length of the project is going to be the length of the critical path. That's why critical paths are so important, because it would determine the length of the project.